Welcome to lesson number 1 with the mathematical reasoning. We're going to look at induction or inductive reasoning, conjectures, and counterexamples today. So this is the first lesson. It's hopefully it won't be too long, and I'm going to try to go through as many of the examples as possible. But remember, if you do need to pause the video at all in order to catch up or rewind it, if you want me to repeat something, that's all in your control. Okay, so with part 1 of this investigation, we have a circle with a triangle that is inscribed or drawn inside of it. So the circle has center at O, and it has a diameter of AB. So the diameter across the center going through O is AB. We want to use a protractor to measure triangle or angle ACB. So ACB would be this angle here, and we want to record our answer. So using my protractor, I'll place it on my triangle, and lo and behold, we have a 90-degree triangle here, or 90-degree angle, a right angle. So we want to record the measure of that angle. That's 90 degrees, a right angle. Next, mark any point D on the circumference of the circle. So any point will do. We can put that point D anywhere. So I'm going to place it here, and then I want to connect this point D to A and B. So here I'm connecting D to A, or A to D. And you should really use a straight edge for this. And then I'm going to connect that point that I just made to B. Again, I'm using my straight edge here. We want to measure this new triangle that I've drawn, ADB. Again, if I use the line that I drew, there we go, line that up, I have again 90 degrees. I have another 90-degree angle that's been formed. I'll repeat this process with 3 more points anywhere in the circle. So let's put a plot there. And again, we want to connect that to A and B. And that's also going to form a triangle if we use the diameter here. And then I want to measure that. And again, there we go. Again, I get a measurement of 90 degrees. Let's try again and let's see what happens. So connect the legs. And measure that angle. Again, we have 90 degrees. So that was 90 degrees there. And I'll do it a 3rd time like I was instructed to do. And let's connect those dots. You're going to end up with several different triangles that are all, perhaps, yes, 90-degree angles, or right triangles. So what conclusion can you make based on your observations from your work and answers? So based on what we observe here, if we were to draw any angle that has a point on the circumference of our circle, so any angle that's made from a point on the circumference, whose arms pass through the diameter, so that point A, or that line AB, so whose arms any angle made from a point of the circumference whose arms pass through the diameter is a 90-degree or right angled triangle. All right, so if I were to continue this process and connect them to AB using the diameter as my other edge of my triangle, my hypotenuse, then I'm going to end up with a right triangle. So if Now, if we move on to part 2, Bruno is investigating a fabric design for new furniture he is making. The original design is based on a trapezoid. His first complete sketches and a third incomplete sketch are shown. So this is the original sketch. This is sketch 1, and we need to complete the sketch 3. So if I were to complete sketch 3, I'm going to assume that he's going to continue this pattern and make some more trapezoids here. So he wondered how many new trapezoids would have to be added in a 5th sketch. So without drawing the sketch, we want to complete this table to see how many trapezoids he would have to add. So with the second one, so for sketch number 1, he had to add 2 trapezoids. For sketch number 2, he had to add 1, 2, 3, 4. For sketch number 3, he had to add 1, 2, 3, 4, 5, 6, 7, 8. And so we're gonna, for sketch 4, if we look at this trend, so 1, 2, 3, 4. So he didn't draw any for number 1, or for the original, sorry, but for sketch 1 he added 2. For sketch 2 he added 4. For sketch 3 he added 8. So every time he adds new trapezoids, the number is doubling. So for 5 and 6, we'll have to add those on, but for number 4, he'll end up with 16, right? Because for sketch 2, that would be, it starts with 2, and it's 2 times 2, and it's 2 times that 2 times another 2, and it's 2, and so on and so forth. So another way we could describe this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Next would be 2 to the power of 4, so he would have 16. If we were to continue this trend, 2 to the power of 5, he would end up with 32. 2 to the power of 6, he would end up with 64. So based on this table, what conclusion can you make about the number of new trapezoids to be added in the 10th sketch? Well, sketch 10 represents base, so 2 to the n, where n is equal to the sketch number. So 2 to the power of 10 would be the number of trapezoids he would have to add. This would be, if you plug that in, would be 1024. So we're going to now look at what we just did. We just went through a process known as inductive reasoning. So on the investigations on the previous page, we based our conclusion on patterns and observations we were making. And so the conclusion we came up with was, well, this rule must be true because the evidence is this. So for example, any angle made from a point on the circumference whose arms pass through the diameter is 90 degrees. That was a rule we made. Another rule we made was that the sketch number is equal to 2 to the power of n. And so for the 10th sketch, we concluded that there would be 1,024 new trapezoids drawn. We're going to look at class example 1 shortly, but we have to know a few more things. So, for example, what is a conjecture, and exactly what is inductive reasoning? Inductive reasoning, so that's a type of reasoning that when we form a conclusion based on our experience or based on patterns that we are looking at or observing. The conclusions then help us to form a conjecture. So a conjecture is our educated guess or the statement that we form based on our observations and experiences. Now, class example number 1 we're going to look at is explain how you use inductive reasoning to arrive at a conjecture from part 1 of the investigation. Well, from part 1, all of the angles that we measured were 90 degrees. all angles were 90 degrees. And since all angles were 90 degrees, we were able to generalize. So we generalized that all the angles or triangles drawn would equal or will measure to be 90 degrees. And for part B, we wanted to state how Bruno used inductive reasoning to derive a conjecture from part 2 of the investigation. Well, in part 2 of the investigation, Bruno observed a pattern and extended it. So now we're going to look at a counterexample. So with counterexamples, that's where we're gonna have class example number 2. So a counterexample is an example which shows that a conjecture is not true. So we formed 2 conjectures earlier on. One was with the triangles, the other was with the trapezoids. And so if we were to find any evidence that would not support our conjecture, that would be known as a counterexample. And that's just a statement or evidence showing that a conjecture is false. It's not true. So with class example number 2, Katie and Perry were given the following number pattern by their teacher. Katie's task was to make a conclusion based only on the number pattern shown with no further investigation. Perry's task was to see if Katie's conjecture was correct or not. So Katie made the following conclusion. When an even number is squared and 1 is added, the result is a prime number. So if I have an even number, it's squared, and 1 is added, I get a prime number. So 5 is a prime number, 17 is a prime number, 37 is a prime number. All these are prime numbers. So Katie's conclusion, what she's formed here, is a conclusion, which is a conjecture. And that's based on inductive reasoning, right? Like she's got these numbers and she's forming patterns using all of these different prime numbers as well as even numbers. But Perry investigated Katie's conjecture further by using even numbers not shown. She correctly stated that Katie's conjecture is false. Determine a counterexample to show Katie's conjecture is false. So all we gotta do is find one example where this is not true. And so let's see what Katie is. She goes 2, 4, 6, and you notice how the 8 is not shown here. So let's try 8. Let's try the same thing that Katie is doing, that Katie is doing. So 8 squared plus 1. And we want to know if we're going to get a prime number here. So 8 squared is 64 plus 1 is 65. Remember that a prime number is one that is divisible by 1 and itself only. But if we look at 65, some factors of 65 are, well, obviously we have 1, we have 5, we have 65, we have 13. So this is not a prime number, which means that this is the example that proves Katie's conjecture wrong. Mick and Sue were discussing what conjecture could be regarding the prime number pattern shown. So 3 plus 5 is 8, 5 plus 7 is 12, 7 plus 11 is 18, and so on. So they both agreed to the following conjecture. The sum of 2 prime numbers is an even number. Provide a counterexample which shows their conjecture is false. Okay, so the sum of 2 prime numbers is an even number. Well, first off, if I start off with an example before 3 and 5, 2 is a prime number as well as 3, and that is not equal to a prime or an even number. That's an odd number, 5. revise their conjecture so it holds true. So let's see, the sum of two prime numbers, and if we look at, what if we do this with 2 and any other number? 2 plus 7 is 9. 2 plus 11 is 13. None of those give us prime numbers. So the sum of two prime numbers excluding 2, and then we continue on this conjecture, is an even number. Is an even number. And finally, make a conjecture based on the number pattern if the condition prime number was removed. So if we remove prime number, we could say, though, that the sum of two odd numbers is even. All right, last example we'll look at today is class example number 4. So we have Jerome, and he's investigating the following number pattern. So 1 plus 2 plus 3 equals 6. 5 plus 6 plus 7 equals 18. Negative 6 plus negative 5 plus negative 5 equals negative 15. Negative 12 plus negative 11 plus negative 10 equals negative 33. So Jerome notices that in all the patterns, 3 consecutive integers were being added. Write 2 more number patterns showing the sum of 3 consecutive integers. So 3 consecutive integers, 2 plus 3 plus 4 is equal to 9. 1 plus 2 plus 3 equals 6. 5 plus 6 plus 7 equals 18. 2 plus 3 plus 4 equals 9. Negative 1 plus 0 plus 1 equals 0. So in this pattern, he noticed again that in all patterns, 3 consecutive integers were being added. Write 2 more number patterns showing the sum of 3 consecutive integers. So here we are. Use inductive reasoning to make a conjecture based on the sum of 3 consecutive integers. So if we look at this, 1 plus 2 plus 3, 5 plus 6 plus 7, negative 6 plus negative 5 plus negative 4. If we have, for example, 1 plus 2 plus 3, those are 3 consecutive integers. But what you'll notice is if we multiply the middle number in each case by 3, we end up with the same value. So in this case as well, if we go 3 times 3, we end up with 9. If we go 3 times 0, we end up with 0, which is the same as the sum of the 3 consecutive numbers. So we could say that the sum, here's our conjecture, the sum of 3 consecutive integers is equal to 3 times the middle number. All right, that's today's video. I will encourage you to read the notes in each section. If you want my support doing class example number 5, then we will look at that in class tomorrow. But have a great evening.